before starting this demo, let me introduce myself. So my name is Amar, and I'm part of NetMinion since 4 years now. I have 15-year experience. I have experience in various technology. Firewall is one of them. Apart from firewall, I do have experience on load balancer, router and switching, cloud, and information security. So in firewall, total I have 10 years of experience. And if I talk about Palo Alto itself, so in Palo Alto, I have 7-year experience. So this is brief about me. So I would be taking your session for Palo Alto, right? Before starting to session, I just want to know about you. I mean, if you have any experience on Palo Alto prior to this or any firewall, okay. And what is the motive to join this course? Okay, so that I can understand your requirement. Accordingly, I can plan to deliver this session. So I would start from all right, not an issue. It seems you might have not control to unmute yourself. If no, you can send us over the chat. We will try to unmute you. Hi, hello.
Yeah, okay.
I can hear you now. All right, not an issue. Let me just go through this demo session. Maybe we can introduce ourselves later. Okay, so let me just start with demo. So yeah, I would be talking about Palo Alto in this demo session. So Palo Alto is basically a firewall. Okay, like we have other vendor, Cisco, Checkpoint. Same, we have a Palo Alto as well. So Palo Alto offers some certification into their product, and the certification is PCCSA, PCNSA, and PCNSE. Okay. If we talk about PCCSA, so this is basically for cybersecurity student. Okay, so if you would be pursuing for PCCSA, so you would be able to understand network-based attack or cyber attack, whatever is happening nowadays. So here you are purely talking about cyber security, not the network security. Okay, so you would be talking about cyber security, and especially network-based cyber security. Okay, the course which we are going to cover, we are going to cover PCNSA, which is Palo Alto Certified Network Security Administrator. And here you would be able to understand that how you can manage your firewall. Okay, so basically here you would be able to understand that how you can deploy policy, how you can operate firewall, or how you can manage the firewall. Okay, so that is part of PCNSA. Okay, and then we have a PCNSA course from Palo Alto, which is for Palo Alto certified, which is stands for Palo Alto Certified Network Security Engineers. So here you would be able to get deep knowledge. Okay, and you would be able to show your skills on Palo Alto firewall, especially in the network security section. Okay, so you can say this is kind of advanced level certification that you can pursue. Okay, here if I talk about in our course content, we are going to cover both of them, PCNSA and PCNSE. Okay, now I'm moving to next one. Why Palo Alto firewall is so famous? So nowadays it is market leader. Okay, and you can choose this firewall because this is a next generation firewall. When I say next generation firewalls, it's providing multiple features that is required nowadays. For example, It is providing application layer identification, okay, or application identification. This is required, okay. It can be managed basically with Panorama. You can manage, okay, or you can manage this firewall as a standalone. So if you have multiple firewall and you just want to manage from central location, so for that you can purchase Panorama. You can integrate your all firewall into the Panorama. And if you have single firewall, so you can manage standalone as well. It has an SP3 platform, which is known as a single pass parallel processing. We will talk about that. This feature making this firewall very fast, okay, because it is going to process any packet parallelly. And it is providing dedicated CPU and CPU for management plane and data plane. So that means what? It means if you have a firewall, so basically on firewall, you would have a two plane. Okay, let's say this is my firewall. So in firewall, you would have a two plane. One plane is what? One plane is data plane, where your this plane is responsible to process the traffic, whatever coming to the firewall and going through the firewall. Okay, so this plane would be able to filter the traffic, right? So uh, this is data plane. We have a management plane as well. Management plane. What is the use of management plane? Using this plane, you are going to access firewall. You are going to push the policy to the firewall. You are going to collect the logs into the firewall. So this is a management plane. Now, suppose, let's say due to any reason, the data plane got overutilized. Okay, what would happen? If you have a shared CPU like this way, a single CPU or single memory for data plane and management plane as well. Due to any reason, if the data plane got overutilized, the CPU is going to be overutilized over here. So on that case, you won't be able to access your firewall. But Palo Alto eliminate this problem. What Palo Alto does, basically they have created a two CPU, one CPU for data plane, other CPU for management plane. Now, the data plane CPU is going to handle traffic of data plane, and management plane is going to CPU is going to handle the the process of management plane. So on that case, what would happen? On that case, if there is, you know, any issue on the management plane or in the data plane, so in that case, none, I mean, either of them is not going to be affected. So let's say there is a overutilization of a data plane due to any attack, and you just want to find out what is the reason why this is overutilized, okay, and you just want to push the policy. So on that case, you would still be able to access your firewall using a management plane. So that's the benefit, a dedicated CPU for management plane and data plane, right? So yeah, you can use this firewall on premises, and you can use this firewall on the public cloud as well. So we have a cloud infrastructure, and if you just want to protect your cloud infrastructure, so for that you can deploy a firewall on any cloud. For example, if you have data center on Azure or in AWS, okay, so there you can also deploy the firewall. And Palo Alto, you can collect the log on a central place. That means if you have multiple firewall on a different location, but you just want to sync the log of all the firewall on central location, yes, you can do that. Okay, you can send the log to any log server. Okay, and you can use Panorama as a log server. So if you have a gateway, let's say this is India firewall, this is US firewall, and this is, let's say, UK firewall. So you can send all the firewall to the central location, okay, and from there you can do all the analysis. Please let me know if you have any question. Okay. Now moving to next, we are going to talk here a firewall. You can see that Palo Alto is on top. This is a leader in the firewall series. And after Palo Alto, we have Fortinet, then Checkpoint, then Cisco, Sophos, Forcepoint, Barracuda, etc. So we have different vendor which is providing a firewall, functionality. Okay, and Palo Alto is a leader in the firewall field. Moving to next, if I talk about traditional firewall, so in traditional firewall, how packet gets processed. So let's say you have a firewall over here. This is a firewall. As you know that firewall can provide multiple functionality. That means firewall can do the filtering. Firewall can check URL. Firewall can check intrusion, and firewall can check antivirus as well. So in firewall, we have a different feature. Okay. Let's say any packet hit to the firewall. Okay. This is I'm talking about traditional firewall. So how packet is going to process? A packet is going to process one by one into all module. So first packet would go to firewall module. This is a firewall module. In firewall module, what it is going to check? Firewall is going to check layer 2 and layer 3 networking. That means here it is going to check IP address, HA, configuration management, reporting, etc. Okay. And after that, it is going to check port. Okay. And then on the firewall policy, it is going to check whether the traffic is allowed or not. If traffic is allowed, so now my packet would go to another module. This is another module. And another module that, let's say, URL filtering. So here it is again checking layer 2 and layer 3 networking, HA, config management, reporting, etc. Then port, protocol, HTTP decoder. And then after URL checking, the packet would go to next module, which is, let's say, IPS module. Again, it is repeating same process. Okay. Again, it is checking, protocol, port-based ID, IPS decoder, IPS signature, etc. And now my packet would move to next one, to antivirus checking. So you can see that whenever my packet is going to particular module, it is checking again and again same thing. Okay. You can say this thing is common over here. All these things are common. It is checking same thing again and again. Okay. So if it has, if one thing has been checked in one module, why same thing need to repeat in another module? Okay. So same thing is being repeated in the other module as well. So for that, you can see that this is a traditional firewall. Same packet is being passed through same module. Okay. And things are going to check again and again over here. So we can say that this is what kind of module, functionality firewall is doing, multi-passed. This is multi-pass architecture. Here, firewall is doing same thing again and again. But in Palo Alto case, this is old firewall. If you talk about Checkpoint, okay, or Cisco ASA, this kind of firewall is, follow this traditional multi-pass architecture, where it is repeating same functionality again and again. But Palo Alto enhances architecture, and in its architecture, you can see that Palo Alto is using single pass parallel processing SP3 architecture. So what happened in Palo Alto case? When packet comes to firewall, okay, it is checking multiple things in a single go. So we can say that this is single pass architecture, where it is checking app ID, user ID, content ID, and networking in a single go, in a single pass. A packet do not repeat itself again and again. And to support this, we have a parallel processing hardware. Okay. So on control plane, or we can say we have management, and on data plane, we have a different module to perform all these actions. So these are the hardware basically. We have in Palo Alto Firewall, we have parallel processing hardware, which is supporting what? Single pass software feature. Okay. So everything in Palo Alto get checks in one go. Okay. Packet do not need to repeat itself on different module. Okay. In single go, it is going to check everything. And to support this, we have a parallel processing hardware. For example, to check network related things, we have a networking hardware. To check security related things, I mean content ID, etc., which is part of security things, we have a security related hardware. Okay. And to support app ID, etc., we have a app ID related hardware. So you can see single pass software perform operation once per packet. For example, networking functions, policy lookup, application identification, okay, and decoding and signature matching. It would perform in a single go only. And to support this, we have a parallel processing hardware. So that's why we can say that um, Palo Alto having advanced architecture, and due to this advanced architecture, Palo Alto processing power is very fast. Please let me know if you have any question. Now I'm moving to next one, and we are going to talk here about initial packet flow. So in initial packet flow, this is a basic packet flow of Palo Alto Firewall, where you can see that whenever packet comes to firewall, this is going to process in a 5 stages. The first stages is known as the initial packet processing. So let's say you have a firewall from where your system is sending a traffic over internet. Let's say there is a server, and this is my firewall. And from here, you are generating the traffic to the internet. So you know that we have ingress and we have egress. So in between ingress and egress, we have a firewall. So what happened? Any packet hit to the firewall ingress interface till the egress interface, what all the processing happens, we can understand using this initial packet flow diagram. So in first of all, in first stage, we can say the packet is going to process in a 5 stage. In first stage, it is going to do initial packet processing. In initial packet processing, it is going to look source zone, source address, and user ID. So each interface would have a zone. Usually in Palo Alto, we are going to define zone as a trust and untrust. The interface which is going to connect to the internet, we consider that is untrust interface, and the interface which is connecting our internal network, we consider that is a trust zone. So we have trust and untrust zone. So first of all, it is going to look source zone, whether on the packet source zone information is present, source address information is present, user ID is present. If this is present, packet would go to next process. Here it is going to look PBF, policy based forwarding, or you can say route lookup would happen in this stage. Okay. For destination, if there is a route on Palo Alto, then firewall is going to process that packet for further stage. If there is no route found for the destination, then firewall is going to drop that packet. And then it is going to look the destination zone. On packet, it is going to check whether the destination zone is present or not. Then it is going to check NAT policy, whether on the packet NAT is required or not. If NAT is required, for that NAT, there is a policy present or not. So if everything goes good in initial packet processing, the packet move to next stage where it is going to check security pre-policy, where it is going to check for the destination which you are trying to access, for that destination whether the port is allowed or not. So maybe from here it is going to check 443 number port as a destination. If the on the policy port are allowed, then it is going to create the session. Once a session get created, it is going to check for the application, where it is going to check whether the packet is encrypted or not. If it is encrypted, so it need to decrypt the packet, where it is going to check the decryption policy. Okay. And after decrypting the packet, it is going to look whether for the particular destination application override policy is defined or not. What is the application override policy? Basically, here you are defining custom application. So as you know that Palo Alto is working from layer 1 to layer 7. So on the layer 7, it would be able to identify that the service you are accessing, that service is what kind of application, what application is being used. So maybe you are accessing Zoom, okay, maybe you are accessing WebEx. So it would be able to identify whether user is accessing Zoom or WebEx, okay, or maybe the custom application. So here it is going to check custom application. If you haven't defined any custom application, then it is going to check default application. On default application, it would be able to identify the service. Once the service get identified, then it is going to check security policy. Here you have seen that on that stage, it was checking the security pre-policy where it was checking the allowed port. But in security policy, it is going to check security policy. So basically we have a different type of security policy. For example, we have antivirus, we have IPS, we have file, we have different type of security policy. So it is going to look over here whether your packet is clean or not against different module. Against antivirus, it is going to check whether your packet is virus infected. Against IPS, it is going to check whether you in your packet any kind of malicious attack, or in file, it is going to check whether the file extension that you are trying to access that is allowed or not. So all these things it is going to check into the security policy. Let's say your packet is clean into the security policy. Okay. So against different security profile, it checks, security policy, and your packet is clean. So finally, it go for the post policy processing, where it is going to re-encrypt the traffic if it has decrypted over here. So it is going to re-encrypt the traffic because it need to send to the final destination. So it is going to re-encrypt the traffic. It is going to finally apply the NAT if required, and then it is going to forward the packet to the destination. So this is the initial packet flow that you have seen over here. Palo Alto basically going to process the packet in a 5 stage. Initial packet processing, security pre-policy checking, application checking, security policy checking, and post-policy processing. So these are the 5 stages. On that, Palo Alto is going to process the packet. Any questions so far?
No
Okay.
question.
Yeah, great. Thanks. Now I'm moving to next one. And I'm after, um, talking about a basic introduction of Palo Alto Firewall, I'm going to show you some practical in the lab. Okay. So let me show you lab as well. And there we can perform some practical. To access the lab, you can type labs.netminion.net. Okay, this is our lab module. And you can access your lab by clicking on access your lab. This lab you can access 24/7 from anywhere. Okay. Post your registration, you would get lab access. So whatever the lab you have assigned, you can access your lab. You can see this lab is assigned to me. I can access this lab. There you can say we have a firewall. I'm going to remove the old configuration. We'll do the configuration from starting. So let me just introduce about this lab. In this lab, you can see we have a firewall. So in this lab, you can see we have a firewall. There are two firewall. Okay, Palo Alto 1 and Palo Alto 2. Because why we have taken two firewall over here? Because we will not configure standalone firewall, but we will configure the firewall in a HA mode, high availability mode. That's why we have taken two firewall over here. And you know, on firewall, we have management interface using which we will accessing the firewall. Okay, so management interface is not going to carry any data plane traffic. When I say data plane traffic, that means when you send the traffic on the management plane, this is not going to hit check the firewall over here. It is just it would be just used for accessing the firewall, to access the firewall. So to access the firewall means what? If we just want to configure policy, if we just want to see the settings on the firewall, so we can access through management plane. For this management plane, I would assign IP address 10.0.0.1. And through this workstation, we are going to access this Palo Alto firewall. That means on this workstation, we have to assign one of the interface IP address with same series as we have on the management. From same subnet, we are going to assign an IP address to this workstation. So I'm going to assign the IP address 10.0.0.10/24, this IP address. And using this IP address, I would access Palo Alto firewall. Once I would be able to access the firewall, I'm going to assign the zone. So this interface I would put into the trust zone, Ethernet 1/1, and for trust zone, I'm going to put this IP to this interface 192.168.2.1, and that would be /24. And this interface of the workstation, I'm going to assign 192.168.2.10/24. So you can say that this interface would be part of my internal network, or you can say trust network. Or it would be part of trust network. And then we would have another interface, which is 1/2. This interface I would assign untrust, or you can say external. And for this interface, I would assign IP 100.0.0.1/24. Okay. So this interface, through this interface, I can access this router, which we can say that part of untrust zone. And router interface Ethernet 0/0, I would be assigning IP 100.0.0.10/24. Now, to test all these functionality, whether my firewall is working or not, I would try to ping my external router from this workstation. So if I access my workstation 100.0.0.10, if I'm able to ping that from the workstation to this external router, okay, that means my traffic is going through the firewall. Okay, on the firewall, further we will loop the session. Okay, so this is a single switch. Through this single switch, if I generate the traffic for management, so my traffic would go to switch first, and using this interface, I would be able to access management. But if I generate the traffic to the external network, to this router, so how my traffic would be going? My traffic would be going this way. Let me just take different color. First of all, my traffic is going to hit Ethernet 1/1 interface, then firewall, and through firewall, this is reaching to the external router. This way my traffic is going there. Okay, so let me assign IP like this. Okay, and then I would show you the live traffic on the firewall. So let's clear this and try to, uh, yeah, try to generate the, try to configure the firewall. So first of all, I would access my firewall to assign the management IP. To log in the firewall, we have to provide username admin, and password is also admin. When you are trying to first time login, the firewall is going to ask you uh, admin. It is going to ask you old password so that it can change the password. So I'm going to provide old password admin. New password test @123 test @123. So I'm able to log in the firewall, and I can change the IP by going to the configure mode. So let's go to configure mode and try to change the IP. So IP I'm going to assign as a static IP for our management. So I need to run the command set device config system type static, because I just want to define static IP. And after that, we can set the IP, set device config system IP dash address, and then IP address of management interface 10.0.0.1, and then net mask 255.255.255.0. Commit the changes. Okay, it's showing some error over here because my firewall is still getting ready. That's why it is showing some error. If we just want to force commit, okay, we were just want to do forcefully commit. So we can run the command commit force. It is showing here as well, commit force. Let's commit the changes forcefully. Meanwhile, commit is being forced. If you have any questions, you can ask me regarding this Palo Alto firewall. It is still failed because some of the module is still being is started, and that's why. Let's wait for some time. Let me try again. It seems successful this time because it's taking 55, then 98, and now 100%. So commit has been done. All the changes has been saved. And after this, I can access my firewall from this workstation. So on this workstation, I need to assign one IP that would be belongs to management subnet. So I think I have that IP already. Let me show you. I'm into the network configuration, and over here, if I check this interface, so if you see the IP address of this interface 10.0.0.10, that means I should be able to ping my firewall from here to the management interface. Ping 10.0.0.10. Sorry, 10.0.0.1. I'm able to ping. So if I'm able to ping, I can access my firewall. And there is another interface. For another interface, I have already assigned 192.168.2.10. This is a client IP. So let's log in on the firewall. So to log in on the firewall using GUI, you can type HTTPS and then IP address of management interface. Let me change the password. You can say this is a dashboard of firewall. In this dashboard, you can see device name, device IP address, subnet mask, model of firewall. So this is a basically Palo Alto virtual machine. This is not a physical firewall, but this is a virtual firewall. Serial number, etc. And you can see software version, that means Palo Alto operating system version. Okay, and finally you can see system resources over here where you can see utilization of management CPU and data plane CPU. So we have different tabs. We will discuss this tab later. Okay, we have ACC, monitor, policy, object, network, device. All these tabs we have, and there are different role of these tabs. Using these tabs, you can configure different things. For example, using device tab, you can do the firewall configuration. For example, if you want to change the host name, you can go to device tab, setup, management, general setting. Under general setting, you can change the host name. So I'm changing the host name. I can say this is a Palo Alto 01. That's the host name I have defined. Any login banner you just want to change, you can change that. Okay. In our case, we are going to the configure interfaces. So if you go on the interface, you can see we have Ethernet 1/1, 1/2, 1/3. These are the interfaces we have that you are seeing over here. So for Ethernet 1/1 and 1/2, I would be assigning the IP address and zone for them. To do that, let's go start from 1/1. So for interface Ethernet 1/1, I just want to configure this interface as a layer 3 because layer 3 is supporting IP address. That's why. And on Palo Alto, we have a virtual router. So virtual router is a kind of VRF. If you just want to segregate your routing, so you can create a virtual router over here. So there is a default virtual router in Palo Alto Firewall. I'm not going to create any virtual router, but going to use default one. I'm not going to segregate any routing. And then source zone. So you can create a zone from here itself. You can click on zone and you can say that this interface would be part of trust zone. And then you can say okay, and you can assign IP address over here. For example, I'm going to assign IP address 192.168.2.1/24. This is what we have decided that for internal interface, I'm going to use this IP. And you would be able to see that interface is a layer 3 IP address and its zone as well, that this is part of trust zone. And then we have Ethernet 1/2, and you can say that this is a part of untrust zone. So zone you can define from here, untrust. And then IP address. We had decided that we are going to assign 100.0.0.1/24 IP address. So we have interface IP address is already assigned. We can commit the changes. But if I try to send the packet traffic from my firewall to external router, this is external router. Let me assign IP address here as well to external router. And we had decided for external router, we are going to assign 100.0.0.10. Enable conf int space E0/0 IP address 100.0.0.10 subnet mask 255.255.255.0. The gateway of this interface router would be my firewall. So I'm going to define IP route for any source or destination. It should reach to firewall always. UWR. Now I have defined everything, and you can see policy has been committed, interface is up. But if I try to send the packet from this system to external router, right now it's not going. The reason is we haven't allowed any traffic. We have to allow traffic. By default on Palo Alto, everything is blocked into different zone. So this PC is on which zone? It is on trust zone and trying to access what destination? The destination which is on untrust zone. So it is going to hit the firewall, and then firewall is dropping this traffic. So if you check the policy, in firewall we have a default policy. So default policy, we have two policy. Within the same zone, all the traffic is allowed. So if I send the traffic from trust to trust, yeah, traffic is by default allowed. But if I'm sending the traffic from trust to untrust, that inter-zone traffic, so this policy is denying that. Inter-zone traffic, what it is showing, if the traffic is zone is any, destination is any, okay, but the traffic is inter-zone. So if there is an inter-zone traffic, it is going to deny the traffic. So above these two, we have to create a policy where we can say that if the traffic is coming from trust zone and going to untrust zone, traffic should be allowed. So let me add the rule over here, and I can say that allow the traffic name, policy name, allow underscore trust to untrust. And then we can define source. Source zone is mandatory. We can put the source zone trust. Source IP address that should be defined over here. So let's say I'm trying to generate the traffic from this IP 2.10 single IP, and user is any. Right now we haven't defined any user. Destination, I can say that destination is untrust zone and destination IP is 100.0.0.10. So application, what type of traffic I'm trying to send? Ping traffic. So I have taken ping application, and service, that is application default, and action is allowed. So if I create this rule and then try to ping, whether it should ping or not, it should not ping. Why? Because we have created the rule, but we haven't commit the changes. So that changes is not effective. So we have to commit this. So let's commit the changes. And after that, you would be able to see that my traffic would be allowed post committing these changes. It's committed now. Now try to see. Okay, let me check the gateway. I can debug IP ICMP. Let me check why this is not working. Let's verify policy again. One of the reason is network switch. Let me wipe out the configuration. Maybe old configuration on this switch, and that's why. Sorry, I was pinging wrong IP. I have to ping 10, this IP. And you can see now my traffic is moving through firewall. How I can verify that traffic is going through the firewall? If I go to monitor and then session browser, I should be able to see that session has been created. And if you open any particular packet, You can see that what is the session ID, what is the source, and what is the destination. So you can see source is from trust. Okay. And destination is this IP, and you can see traffic is being allowed over here. And this is return. Flow 1 is from source to destination, and flow 2 is return traffic from destination to source. So you know your inbound and outbound both traffic is going to be allowed. And if you want to see that whether this is just because of this policy, try to disable this policy. Select and try to disable this. And once you disable, commit the changes. You would be able to see that post committing this, this flow should stop. Yeah, as soon as I disable the policy, the traffic has been stopped, and if I enable again, the traffic should get start. I have enabled it. I need to commit them. You can see the traffic has been started again. Okay, so this was a small demo on the Palo Alto Firewall, and hopefully this session was informative for you. If you have any question, you can ask me. No question? Okay, no problem. So let me just talk about what you would get if you're joining this course. So if you are joining this course, you are going to get recorded video for these live classes, workbook, lab, and the support.